Good morning. Let's go ahead and start off with a review from our place value lesson that we had yesterday. So I went ahead and gave you the standard form of this number, 75 and 614 thousandths. We'll begin by writing it in expanded form, and I left us some space here to do that. When we take expanded form, we're taking the number and we're stretching it apart, we're breaking it apart into its place value positions. So I have 7 in the tens, which gives me 70. In my ones place, I have a 5, so I'm writing plus 5. And now all of my numbers are after the decimal. So 0.6 shows that I have 6 tenths. 0.01 shows that I have 1/100th. And now finally 0.004 shows that I have 4 in the thousandths. If you were to do that extra special second step, remember we're going to take the first number out. I know some of you yesterday were working on this second step. You take the digit from each place value position and you pull it out and replace it with a 1 that you end up multiplying by. So our 7 actually becomes 7 times 10. Our 5 is 5 times 1. I'm showing you what's in the 10 spot, what's in the 1 spot. Now I'm showing you the decimal portion of our expanded form. The tenths, I'm pulling out this 6, so I'm multiplying that by 6. Plus 1 times 0.01 plus 4 times 0.001. Alrighty. If you prefer fractions, your expanded form would look really similar. We have 70 plus 5 plus something over 10 plus something over 100 plus something over 1,000. So in the tenths place we had a 6. In the 100ths place we had a 1, and in the thousandths place we had a 4. So those become fractions out of 10, 100, and 1,000. Okay? If you were to turn that into an even more simplified version of the expanded form, our second step, we would just pull out those digits and make them 1. So this is 7 times 10 plus 5 times 1. It's showing you the tens place, the ones place. And now something times 1/10. Something times 1 over 100. And something times 1 over 1,000. And now we fill in those somethings. So in the tenths place, we had a 6. In the hundreds place, we had a 1. And in the thousands place, we had a 4. We're going to write the word form of this problem now. Go ahead and pause the video, whisper to the person next to you when you get to this part. What do you think the answer is for this, for the word form of this number? How would we write that? Tell the person next to you, pause the video, and then you can unpause to see the answer. Hopefully, you and your partner came up with 75 and 614 thousandths. The key word that we were practicing is and. When we see a decimal point, we say the word and. We do not say 614 because that would mean we have another decimal place in there, and that's not right. So 75 and 614 thousandths. Let's try one more review problem. You can ignore this little scribble. And I already wrote the standard form for you. We'll start with the word form this time. 40, I have nothing in the ones place, so this is just 40. And there's my decimal. 803. You might be tempted to say 803, but that's not correct. The and is only where we have a decimal point. 40 and 803. And now I'm missing one word at the end. Can you think of what that word is? It tells you what position this 3 ends in. If you said thousandths to show us that decimal place value position, you are correct. And now let's go ahead and do our standard form. We'll start with the decimal version. So I have 40 plus nothing in my ones plus 0.8, nothing in my hundreds, so I can leave that. But I do have something in the thousandths, so I need to show that there's nothing in the tenths, nothing in the hundredths, but I do have a number in that thousandths place value spot, and that's a 3. The extra special second step would be to pull these numbers out. So 40 becomes 4 times 10. 8 tenths becomes 8 times 0.1. And 3 thousandths becomes 3 times 1,000th. And if you wanted the fraction version, we have 40 plus 8 over 10 plus 3 over 1,000. That one's pretty short. And that second step, 4 times 10, 8 times 1/10, and 3 times 1,000. Hopefully that's becoming a little bit more clear, and we'll continue to review that as we work on place value for the next few lessons. Let's write our new objective for today. I can compare decimals to the thousandths using like units and express those comparisons with these symbols. So they look like little Pac-Man or alligators. Hopefully you've seen them before. Greater than, less than, and equal to. You can remember less than because it looks kind of like an L. We're using these symbols to show which number is bigger or has a greater value. Let's start by reading the numbers. 13,196. 13,296. Think in your head, which number is greater? How can you tell which number is greater? Well, 13,296 is greater than 13,196 because the digit in the hundreds place is 1 greater. See, our 13,000 is the same, or I could even go the 1 in the thousands in the 10,000 spot is the same as the 1 in the 10,000 spot. The 3 in the 1,000 spot is the same as the 3 in the 1,000 spot. Here is where the numbers become different, is in the hundreds spot. The digit in the hundreds place here is 1 greater. 13,296 is 100 more than this number. 13,196 over here has 131 hundreds, and our second number has 132 hundreds. So this number is greater. We're going to use the symbol less than to complete this sentence. 13,196 is less than 13,296. And another way you can remember how to use these symbols is that the open side, where it opens, always points toward the bigger number. Okay? Let's try a problem that has decimals. We'll start out by writing this in our place value chart. So you can go ahead and write both numbers on your plastic dry erase place value chart. You should have 0.002, and then you should have 0.012. And now we're thinking which number is greater. If you need to, you can pause the video, turn and whisper to your partner about which number you think is greater and why, if you and your partner next to you or at your table are kind of around the same spot in the video. Or you can just think in your head which number is greater. We have 12 thousandths or we have 2 thousandths. Well, 12 thousandths is greater than 2 thousandths. In 12 thousandths, there's a 1 in the hundredths place, but 2 thousandths has a 0 in the hundredths place. And I can highlight that digit to show you there. 0.0 is the same as 0.0 here. Here's the first difference in digits is once we get to the hundredths place. So they're saying this 1 in the hundredths place is greater than the 0 that's in this hundredths place. That tells us that 12 thousandths is greater, so I'm going to have my greater than sign open up toward the bigger number. 12 of something, even if it's thousandths, is greater than 2 of the same thing. Just like 12 apples are more than 2 apples. So we have our final expressions here comparing some numbers. When we have this number sentence, we can call it an expression because there's numbers that are being compared or worked with and there's no equal sign at the end telling you the answer, even if we might use the equal sign to compare. The next problem that we're going to do has a little bit of a different twist on it. We're still comparing numbers, but I gave them to you in fraction form. We're going to write both of these in standard form on our place value chart. So even though they give us fractions, we'll put them into a place value chart so that we can see how they're written as decimals. Let's start by writing 3/10 in standard form. I would have 0.3. 3 out of 10 would be 3/10. And I have 299 thousandths now written in standard form on the place value chart as well. Which decimal has more ones? Well, that was a trick question because neither of them have a whole number attached. So they both have 0 ones. Now we move over, we skip the decimal spot. Which number has more tenths? Does 3/10 have more tenths, or does 299 thousandths have more tenths? We're just focusing in on this column. Well, 3/10 has more because 3 is bigger than 2. If we traded 3/10 for thousandths, how many thousandths would we need? Now's a good time where you can pause, turn, and talk with your partner if you need to. The question was, if we traded 3/10 for thousandths, how many would we need? Hopefully you and your partner brainstormed, maybe you got out some base 10 blocks and you said, well, you would need 300 of these thousandths pieces to equal 3 of these tenths. We can now name these decimals in standard form and compare to figure out which one has a greater value. 299 thousandths, or we turn this into 300 thousandths. 300 thousandths is greater than 299 thousandths. So we would fill in our expression up here with the less than sign. 299 thousandths is less than 3/10. Even though 3/10 looks smaller, It's actually worth more thousandths. For the final problem, you'll have to put numbers in order. Sometimes it'll say from least to greatest, sometimes it'll say from greatest to least. You've probably done this before with whole numbers. It's a little bit different with decimals, only because you need to look at the numbers that come after the decimal point. You can use a place value chart to compare, just like we did up here. You might be able to work by the digits. So I'm looking for the tenths place first. Since none of them have a whole number in front, they all start with 0 point. Which one has the smallest value in the tenths? Is 4 the smallest, 0 the smallest, 1 the smallest, or 5 the smallest? All right, well, hopefully you said 0 is the smallest. So I'm gonna write 56 thousandths first. Next, 1 is the smallest out of 1, 4, and 5. So 164 thousandths comes next. 413 thousandths is next. And then finally, 531 thousandths is the greatest. Just pay attention, because if this said greatest to least, your whole answer would be backwards. This is a lot like alphabetizing words, like we've been practicing also, because if you happened to have two numbers with the same digit, like if we added 422 thousandths, now I have two numbers here and here with a 4 in the tenths place. I would need to go to the next digit over and look at this 1 and 2 in these spots to determine which one comes next. Now that your notes are done, you can go ahead and work on your group problems or the problem set that is posted on Google Classroom. Thanks so much.